losing the lottery, for you guys. But, yeah, composting, I think with the livestock thing, I think that's kind of what we're doing on the farm. I think that's one of the reasons we put it in. We compost for our garden. And Ruth did that yesterday where she talked about how we do our no-till garden and how we use our compost and stuff there, but we don't have the vermi stuff, so I don't know if I can add anything to it. I do think that oat seed, if it was growing somewhere where they had mycorrhizal fungi, it would probably have some mycorrhizal fungal spores on that oat seed unless you, depending on what you did to treat it. So I think that's one of the things that should be looked at in terms of things. But you guys, Chris couldn't make it. I looked at a couple things to do that are along that line. There seems to be a lot of questions about carbon and carbon sequestration and how much you're going to get paid. I don't think you borrow any money against what they're planning to pay. Let's put it that way. Wouldn't be. But we've been talking about this for a long time. I left that on. I should take it off. There's been a study done. Actually, this was on NPR the other day. The study that they did where they took people and showed them photos of different people, and on average, they found that people that were wearing masks were better looking. So I'm going with that. I'm going to ride that horse along as far as I can. I need all the help I can get. So. Do you see what I see? This is from a 2005 presentation. So science doesn't change. So I went back, and if we're going to talk about soil biology and whatever, and everybody wants to talk about carbon again and carbon sequestration, I thought I'd go back and build off of that. So. Just, nothing on Dakota Lakes. You guys had all that already today. I like to show people where we're at. If they're from other places, they don't know where South Dakota is. We go somewhere, well, I'm from South Dakota. They go, I have no idea where that is. Go overseas, they really have no idea where that is. So you show them Minneapolis and Denver, you may have a chance. You talk Mount Rushmore, they understand that. Sturgis and Dances with Wolves if they're old enough. They remember the Dances with Wolves thing, right? And I always say we're nowhere near Brokeback Mountain, but I can't say that anymore. So anyway, and showing what the native vegetation is. I showed this slide one time in Australia, and they asked me where the trees are. Because in Australia, every place that you farm is a bush, is trees, tall trees, big forest land. And they said, where are the trees? And I just jokingly said, Paul Bunyan cut them down. Of course, they didn't have any idea who Paul Bunyan was either. So then you have to backtrack and start to try to figure it all out. So you're just better off not to be a smart ass sometimes. Okay, here we go again. They told me they had this fixed. I'm going to bring my own computer next time and just do it from up here. Help me. Okay. So part of what happens is it depends on your native vegetation. Probably the slide before this was of the river hills next door, but we're combining irrigated corn. My irrigated ground is Iowa. My dryland corn there, and that's an old combine too, 9410, and it's got a yield monitor that's for Anthony. So I took that picture. You got to slow down real fast, and then it'll do that for you. Why we and most other irrigators now in the area use no-till has to do with this water thing that we did. The night crawlers are an important part of what we do, and when they talk about composting, I think the night crawlers are doing that for us. And our earthworms, and that's the way it naturally would occur. They're cycling things and doing things and whatever, so I'm not sure we're going to get into doing a lot of that, but maybe Sam will, I don't know. But we show people this all the time with these night crawlers, and they pull that leaf down in the soil, and then they grow fungus on it, and they eat the fungus. That's what a night crawler does. A few years ago, just before Dugard left office, I got a call from his secretary saying, Governor Dugard would like to visit Dakota Lakes. Is that okay? So what are you going to say? No. Stay the hell away. We don't need you here. And so, yeah, we're happy to have him, and we did some little background. He's very punctual. He likes to start on time and end on time and whatever. So we were all ready to go. We told the people at Brookings that he was coming, be there on time. Of course, they were late. But we started without him. And I show him these night crawler holes, and there's one every 9 inches, because the reason I talk about night crawlers is they're the animal on top of the food chain. So if you want to evaluate a regular ecosystem, you look at the eagle or the wolf or the lion, because that's the top of the food chain. The night crawler in our irrigated ground is the top of the food chain. So if he's doing well, things are better, right? But anyway, we're showing them these, and they're 9 inches apart, and that the night crawler is hermaphroditic. It has both sexes, right? And so any two of them can tangle, and I'm doing that, and my wife Ruth is standing behind the governor doing this, because she knows my next line, because she's been there long enough, and she don't think I should go there. Because I tell them that, and the only time they leave that hole is to either drill a new hole or to have sex, and any two of them can have sex, and then my next line is, and now they can get married and get insurance. And I thought, what the heck, he's going to retire anyway or quit, and I'm going to retire. So I just went there, and he says to one of these guys, that's really good, we should write that down. So anyway, I am a farmer. I take sunlight, water, and carbon dioxide and turn them into products I can sell. That's basically what I do. And fertilizer isn't mentioned there or anything like that. It really has to do with capturing carbon dioxide and water. Address the problem instead of treating the symptom. If you do things like terraces, we went through Missouri. There's all kinds of terraces in Missouri. All they do is make it really hard to farm. Hard to find the truck in the middle of the night, or the grain cart, okay? So you should try to the reason they put this terrace in is they had runoff. But if you no-tilled it, you wouldn't have runoff. North Dakota, you see a lot of tree belts. Same reason, they're trying to stop wind erosion. If you did no-till, you wouldn't have wind erosion, okay? And we saw all those terraces in Missouri, and they really make it difficult. Mother Nature's an opportunist. If you have a problem, you provide the opportunity. That has to do with resistant weeds and things, right? This was, again, way back in the 90s when cyanamide, who had pursuit, said there wouldn't be any resistance to pursuit. They were wrong. I said they would get it. I got threatened with a lawsuit, so we proved it. And then whatever, we now use pursuit again. You can fix that. Strive to produce a crop which is healthy, not one that doesn't get sick. And one of the things we're doing now is you're letting people scare you, maybe not as many people in this room, but a lot of the farmers. They're scared everything's going to get sick. So they put on the fungicide and insecticide, just spraying that stuff all the time. You shouldn't have to do that. We have not used an insecticide at Dakota Lakes in 18 years. Okay, because we have predators and things like that, and those are a function of having good things going on in the soil as well. But then none of that happens if you do tillage. So, anyway, it's really this kind of thing. We're going to talk about the carbon thing this afternoon in the soil biology some, but if you just take tillage out of that circle, the circle collapses. And that's what a lot of our no-tillers, quote unquote, in South Dakota have done, is just quit doing tillage and start replacing tillage with technology, and there just isn't enough technology available. And so we're going to get resistant weeds or we're going to fail. Cultural practices, technology, and management, you have to replace the tillage with other cultural practices. Now, if you could only know one thing about a soil, They said, you're going to rent this soil, but I'm going to only tell you one thing about it. What do you want to know? I mean, you know where it's at, but. How about organic matter? Because infiltration rate's related to that, right? That would tell you more than anything else about, if you know the location, what's the organic matter there, about past management, such things. Reducing this organic matter by 2% is the same as shipping one 80-car train load of coal from each 1/2 section of land. Almost everybody's land here has lost 2% or more. You go to places in Iowa where they started at 12% and they're down to 3 or 4%. And that basically all got burnt by doing tillage. Stirred the fire and the organic matter burned up. And when it comes to organic matter, there's terms for this, okay, that talked about easily oxidizable organic matter and resilient organic matter and whatever. I like to say organic matter, there's the living, the dead, and the very dead. Okay? But it's not all the same. So if you started out at 12% in Iowa and you're down to 4%, the only thing that's left is the very dead. Whereas if you're in South Dakota and you started out at 4% and you're at 3%, you got a lot of good stuff left there. So just knowing how much organic matter isn't enough. We need to know a bit more. What does this mean to global warming? Well, 100 pounds of dry soil with 4 to 5% organic matter can hold 165 to 195 pounds of water. With 1.5 to 2% organic matter, it can only hold 35 to 45 pounds of water. So you think of this year when it was dry and whatever, the guy that had the bigger bucket, the soil that held more water, wins. Now, how many people here know about Web Soil Survey and Web App and whatever? If you don't, you need to go find your nearest NRCS person and learn. How about the students? They teach you that? Did Fred teach you that? Oh, Mr. Zink? Okay. So that's the most powerful tool that we have in the United States, and no other country has that. So I travel around the world. You've got to guess at what the soils are. In the United States, I pull out my phone, push a button, and I know what soil is there. Okay? And NRCS doesn't measure this difference. They're saying what would have been there if you wouldn't have screwed it up. So if you took it from 4.5 down to 2.5 or 2, that's your fault. What does this mean for crop productivity and stability? Well, the better organic matter, the better, right? And then we have a thing called tillage erosion. When we started a soil profile on a hill, like over at Webster in that area, it would look like this. A little organic matter in the top, more organic matter in the bottom, but there's topsoil all the way. And as we do tillage, we pull that top off and take it down in the bottoms. Okay? That's tillage erosion. Now, one way you fix that is you do bale grazing and put the bales on top of the hill. And you grow them in the bottom and you put them on top and you graze the cows up there and they poop up there and eat the hay, and you're basically taking the organic matter back to the top. It's one way to do that. So that's what it looks like. Those are called the buckskin hills. Sooner or later, you'll start pulling subsoil down over top the topsoil, and then you really have an issue. So, does NRCS consider tillage erosion in the Russell equation? No. Why not? If they did, there wouldn't be anybody in compliance in the whole United States. Right? And that'd make everybody mad. And then they'd call their senator, and the senator would call NRCS, and whatever. Soil carbon is critical to soil health. Infiltration rate, so that's why you said infiltration rate. Water holding capacity, nutrient exchange, how much you can chelate, how much cation exchange capacity you have. Oxygen exchange, which I think is one of the really big things. And then promote soil life. And the reason they say oxygen exchange, you can't make water go in the ground unless the air can come out. And you really can't. In the old days when, God forbid, we used to do tillage, and I wasn't very old when I quit doing that, but you'd get a rain and everything would turn yellow. And you'd cultivate between the rows and it'd turn green again. Well, that was a lack of oxygen in that soil. And with our big macropores and our irrigation stuff, that never happens. We occasionally will have an irrigator get confused in the middle of the night and stop, and it just sits there and waters for 6 or 8 hours. So it's maybe put on 15, 20 inches of water, and we still won't have anything turn yellow because it can breathe. That water goes down in there, and then it always leaves that hole open to let air come in. So, organic mineralization. Organic matter consists mostly of carbon, some nitrogen, and sulfur, and other nutrients. When oxygen is present, the organic matter burns, produces carbon dioxide, water, ammonia, and other nutrients. Okay? That's a chemical process. It's a controlled burn when it mineralizes. Okay? And I used to teach chemistry. That should scare the students. I used to teach chemistry. And math. Anyway, immobilization is a process of making organic matter. And what it does is nitrogen in the mineral or losable form is taken up by and immobilized by plants or soil microorganisms. So it's put in this non-mineral form that goes away. Now, for you older folks that took soil fertility or agronomy or something, they go, oh, if you got a lot of straw out there and you're going to put on nitrogen, you got to put on more nitrogen if you got straw out there because it's going to immobilize, right? That's a bad thing, that immobilization. Oh, it's going to tie up our nitrogen. It's going to keep in the form that's not going to go in the river, but it's making organic matter. So those two are just opposite processes, right? Nitrogen immobilization and carbon sequestration are exactly the same thing. But we go, oh, we're going to sequester some carbon. Well, that's nice, but you got to have nitrogen to do that. Oh, I'm immobilizing my nitrogen when they do that. Bad thing. No. They go together. They came out together. And the reason people used to do summer fallow and do tillage was to mine the nitrogen out of the organic matter. That's why all the summer fallow was out West River. It wasn't to save moisture. And that's why our grandparents did tillage. It mineralized the nitrogen. We could use that nitrogen because we didn't have nitrogen fertilizer until in about 1950s. Carbon sequestration had a better press agent, right? So we'll call it carbon sequestration. But realize if you're going to sequester carbon, you have to put nitrogen with it. You have to put enough nitrogen with it that it stays. So here's this carbon cycle. You got all the microbes down below, a lot of stuff happening on top. In the temperate areas like here and the drier areas, you will have higher organic matter in the soils than you will in the tropics, where they get good moisture and stuff. So you go to the tropics, everybody, oh, they're really low in organic matter and they're terrible soils. Well, all the biological activity is happening above ground. You don't need to have a soil with a lot of organic matter for all the activity to happen there because we get this thing called winter. In the tropics, you have it all going on up above. So it doesn't make any difference. When plants immobilize N, they also immobilize C from the carbon dioxide. When soil microorganisms immobilize N in the process of decaying, high carbon nitrogen ratio residue, it prevents the carbon in the residue from being lost from the soil. So you got to have the N in there or that carbon will just gas back off again. That's basically what it's saying. If you put sawdust in your soil, what's it do? Just ties up all the nitrogen, right? Because you didn't have enough nitrogen there. You got to keep that balance there. Immobilization means we have converted mineral N to organic N. When we're led to believe that immobilization is a bad thing, but it's only bad if you don't want it to happen. So you got to understand what's happening when you start dealing with these things. And a good example of that is cover crop. If you put in rye cover crop and you plant green in it, and everybody goes, well, if I plant green into that rye cover crop, lillipathy gets my corn. No, what gets your corn is lack of nitrogen. Because the rye has the nitrogen all in it, and it's not giving it off. And I showed you this morning we needed to give that corn some nitrogen early. So if you're going to do that, make sure you fertilize the corn, sideband the corn. I'd still kill the rye before I planted the corn, but whatever. With tillage-based farming, we sped the breakdown mineralization of organic matter while reducing its formation. So we got to mine that nitrogen out of there, and that's what we did for the last 120 years. Send Grandpa the bill, if you must. You know, he used it. But that's why we have lower organic matter. So here's arrows for the slow. Sod, you got mineralization and mobilization going the same speed. If you till it, mineralization is greater than immobilization. Right? Is that clear? This is just like school. In other words, with tillage, we mine the organic matter by speeding the decay. It's beneficial for crop growth. This process is slowed in no-till because the soil is cooler, and the organic matter is exposed to less oxygen. When you do tillage, it's like stirring a fire in the fireplace, right? So with no-till, you're not doing that. The process occurs later in the year. In natural systems and in no-till, the mineralization that gives off the nitrogen occurs later in the year. And if you were in here this morning, I said, put some starter on your corn and come back out at V6 and test again and see what you have before you buy a whole bunch of fertilizer. You know, you put some by the row, put 30 pounds by the row and come back at feet 4 or 5 so you can wide drop it before V6 and see how much is released, because it'll start to release by then. Occurs later in the year. With wheat, for instance, occurs later in the year, gives you higher protein. Legume crops produce N for themselves. Little of that is left behind if the crop is harvested for grain or the forage is removed. You don't get nitrogen from a legume that you get to keep. And you thought differently, right? Everybody says, oh yeah, I get a credit. You get credit, but you don't get any real nitrogen. It's like having credit at the feed store or something, right? Legume crops give you a nitrogen credit the year following their production. This is not due to the fact that they have left lots in N, but because they have less carbon. So you're not making as much organic matter. So you got leftover N because you don't have enough carbon to make the organic matter that you normally would make, because the legumes are wimpy. And if you take it off, same thing happens. The same thing happens if you take corn stalks off. Same thing happens with sunflower. Anything that reduces your carbon out there, you're going to make less organic matter, so you need less N. That leaves a little extra for you to use, but you're getting it because you mined it from organic matter. Not a good deal, necessarily. This is, in other words, the nitrogen credit the year following the production is due to the fact you made less organic matter. This is similar if it's an impact to doing tillage, in that the amount of organic matter is reduced that year. So the year after wheat, if we don't do anything else, it's like the top one. The year after legume crop, you can see we make less organic matter. It is similar to burning or baling straw from a field. Immobilization making organic matter has been limited. It is also similar in the impact of doing tillage, in that organic matter is reduced. So, nutrients lost by burning straw. I like this one. If you burn your straw, 50 pounds the acre of N, 82% of it's lost. 5 pounds the acre of 75 bushel acre wheat crop. 5 pounds of P, 44% lost. 100 pounds the acre of potassium, 40, and 3,000 pounds of carbon, almost all of that's lost. Now, if I remove that, if I removed it instead of burned it, that's even worse, because 100% of it's gone. Worst thing you can do to your ground is to put alfalfa in there, take it off, and sell it. Okay? True story. I have a guy I know. I'm kind of like Anthony. I have a friend. I might name his name if you ask me. Anthony doesn't do that. And he's a no-tiller, but he grows alfalfa in his rotation and sells the alfalfa. And his neighbor is a corn-soybean guy that does minimum tillage. And they came out and did soil health assessments of the side-by-side two fields. And he called me up and he told me what had happened. And he said, guess who's got better soil health? I said, your neighbor. And it was just silent. He said, yeah, how'd you know that? And I said, because you sell all your alfalfa. And he doesn't sell anything. He's not taking any residue off. He's a crappy rotation. His soil's not very healthy, but yours is even worse because you're doing corn, soybean, corn, soybean, corn, soybean, no-till, and then 5 years of alfalfa and selling the alfalfa. It all comes down to organic matter, okay? Growing plants capture carbon dioxide. Carbon needs to be added continually. Carbon leaves naturally. Tillage speeds the loss. Manure compost adds carbon. It's a concentration of plant material. If I look at corn, soybean relative soil carbon percent, it's a decrease. Corn and small grains, it's a slight increase. Corn and grass or forage, it's a bigger increase, right? Carbon source, increase in soil or carbon, alfalfa is the lowest, straw, manure, and peat. Because alfalfa has a very narrow carbon-nitrogen ratio, so a lot of that goes away. I made the analogy the other day to somebody with livestock about feeding alfalfa and stuff, and then soils and whatever, and I said, it's like having a diet that consists of all candy. If you have too much candy, it's not a good thing. A little candy's okay. But the carbon is the thing. We think our crop rotations, if you're here this morning, we think we need to have 75 to 80% high carbon compounds in our rotations in order to get the goodies. And if you really want to see a good thing on this, go to our website and look at our virtual field day from a year ago, 2020. They came out and filmed me going through all these different rotations with a spade and showing you what the soils look like. And it's very, very evident what influence that has of the different rotations and what's happening there. So, if you take all the top off, you don't get any roots when you graze. And that's what happens to a lot of our grasslands. If you take a little, if you were at Ruth's thing on our garden, I will take a weed eater and whack the tops of some of the cover crops off so they don't head out. And then that makes them tiller and grow more roots, right? It's like a light grazing. Soil microorganisms are like livestock. They're most like cattle. They don't do well on a diet that's not balanced. And then don't bring them home unless you can feed them. If you're going to do too many broadleaf crops, you're not going to have the microorganisms you need because they're not getting enough carbon. They're like cows. You got to feed them a lot of carbon, and that's good. But a lot of your cover crops, everybody goes, oh, I grow radishes and hemp and whatever, and they have no carbon. You know, we seldom put any of those brassica type things in our crop rotation. I mean, our cover crop mixes. They don't have enough carbon. So there's a brassica thing in corn. That corn stock, I mean, there's places to use the brassica where I have 260 bushel corn. I'm growing corn on corn. That might be a place because I want to get rid of some of that residue. But in most of our cases, we don't do that. Organisms pound of live weight in an acre, 1,000 pounds of bacteria, 1,000 pounds of actinomycetes, 2,000 pounds of mold, 1,000 pounds of algae, 200 pounds of protozoa, whatever, 2,000 pounds of plant roots, 1,000 pounds of worms. That's like an elephant. You know, it's like an elephant per acre out there, if you add that all up. And we just totally ignore it. Now, if you do tillage, there isn't any of that there, or very little of it. Most of it's dead and gone. Only plants capture carbon dioxide. Sequestering carbon means growing more plants, growing plants longer. Cover crops are perennials, and I think we're going to have to do perennials. Managing plant growth by grazing management. And I think we're going to have to do perennials to get our lime thing figured out, you know, so we're not buying lime. I don't know why you would buy lime and put it on when you have lime at 4 feet. You know, seems to me you got to be easier to get it from 4 feet down to here than go to Iowa and get it. But I'm kind of a stupid guy. Carbon sequestration means reducing erosion. Carbon's on the top, reduce tillage. You're stirring the fire, recycling plant growth, residue, grazing, not taking it off, keeping the soil cool, covered, adding nitrogen to go with the carbon, just the right amounts of nitrogen. So here's that slide I showed you from Argentina, where they were doing 7 years of grazing and 7 years of pastures, or of cropping years ago, and that's what that looked like. I mean, that, if you don't even have to do anything else, you just look at that. Or you can smell it, right? And you know what you have there. Like cattle and other farm animals, soil livestock require proper feed. Here's one of our cover crop things on the right. That's a hay millet type thing. We do quite a bit of that. We'll swath that and graze it during the wintertime with our cows. I don't have those pictures in today, but you've probably all seen them. And just leaving the stuff on the left, nothing happens. I've wasted sunlight. Ask yourself what percentage of the sunlight that falls on my ground do I capture the carbon with? That's your engine. So, now, this isn't new. I took this slide here at Redfield when I ran the Redfield farm in the 80s. Right? We did small grain first, and then we did forage sorghum sudan after. What was I doing wrong? Look at the right side of the picture. I was making silage out of it, taking it to the feedlot. It's not going to make it back. Especially the nitrogen doesn't make it back. It goes away in the feedlot. And I learned this when my Argentine friends came and they drove down the roads in South Dakota and they watched everybody bailing. And they got to my farm and they go, "So, Dwayne, the cows in Dakota have no legs." So I went, okay, they got me there. You know, that's right. So yeah, we've been doing this. We did some things with sun hemp and hairy vetch, which those are all very high nitrogen things. That has to be done only when you're in between a couple big corns or something. And sun hemp, of course, doesn't do much here unless you grow it as a full season. But it's pretty spectacular. Okay. Now what did I do? Next slide, please. You fixed me last time. One more time? No. 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 There we go. So there it is. And it's like August. And then we've got our own roller crimper. Right? We had that long before. This photo is sometime in the 1992 or 3 range. Okay? And I had a 1010. It was me running that, pulling it with my 1010. And crimping on the sun hemp, and then the hairy vetch is fine. It was kind of cool. We never did that again. But flying cereal into soybeans, this photo was taken, we did that actually at Redfield in the 80s. So that thing works. There's rolled down rye at Pier, again in the early 90s. The trouble with us, we can't get the rye big enough to roll and then plant a crop and get a second crop, right? But it kind of works. It's big stuff. Here's some more cover crop that was lentils and some clovery type things. If you get stranded in the rain in the back 40, you drive home across a tilled field or the pasture. The pasture. That doesn't translate either. If you say back 40 in Germany or in France, they go, "What the hell? What's that mean?" Can't use those. Okay, just things. Cover crops can do some things for white mold, and people ask this question. You got to be a little careful about cover crops and white mold, but here's a study that was done in Wisconsin. If you grew a cover crop, wheat, soybean, oat, soybean, barley, soybean, or soybean alone, they had higher yield where they did the cover crop, and they had higher yield when they did the cover crop because they got rid of the white mold fungi. The sclerotia, the little rat turd type things that are the resting bodies, are laying there waiting for a canopy. As soon as you put a canopy over them with the wheat, they would make their apothecia and try to attack, and of course they can't attack wheat, and those guys would all be gone by the time you plant the soybean. So that's what's going on there. Same thing happens with other leaf spotting diseases. If you put a cover crop on, they'll try to attack. So be careful what you put in your cover crops. We had a wheat green fallow out West River in the 90s in a study, and it consistently had less disease than the wheat chem fallow, just because we put the biological time in there. Okay? Right on clue, my biological time. So, conceivably, the attainable yield of wheat could be limited by the supply of carbon dioxide for photosynthesis. So we're talking about having high CO2. We are. This is an old book. We have better yields of C3 crops now than before because our CO2 levels are higher. Plants don't open their stoma to let water out, they open them to let CO2 in. So if you have higher CO2 levels, you will use less water to do the same thing. And especially C3 crops. If you put a wheat crop in a corn crop, or a wheat plant and a corn plant in a sealed container, the wheat crop, the wheat plant will run out of carbon dioxide and die. And the C4 plant, the corn, will continually go on. Okay? The C4 plants, sorghum, corn, millet, whatever, have a Krebs cycle that has a turbocharger on it. I hope there's no plant physiologist here. But that's basically what happens. And I think what happens in our no-till that gives us better yields than we ever imagined, especially on C3 crops, is because we have if you do tillage, all your carbon goes away right away, and it goes off to the neighbors, and the nitrogen stays there in the ground. If I don't do tillage, then as I develop a canopy, just like the prairie does, as I develop a canopy, the stuff underneath starts to decay, and it's feeding CO2 to my plants from underneath while it's feeding nitrogen into the soil. Okay? Remember this thing years ago, they said, well, talk to your plants, they'll do better. What are you giving them? Carbon dioxide when you talk to them, right? Like, duh. That was a big revelation to somebody. It's a little hard to do on 1,000 acres, you know. Maybe my third daughter could do that. So maybe carbon dioxide level can be changed through management. Here's where we're trying to increase it. Perhaps some of the improved water use efficiency results attained with no-till build can be attributed to enhanced CO2, and we're trying to get set up to actually document that. So here we are. Initially, first 5 years, low organic matter, low residue, carbon structure, regeneration of microbial activity increases. More needs of N. You need more nitrogen. Okay? The next 5 years, organic matter accumulation, more residues, soil aggregates start to form, soil microbiology starts to improve, immobilization is greater than mineralization, which means you still need a little extra N. And SDSU tells you if you're no-till, you need to put on 20 pounds extra N. Well, only in the first phases. Or you do more legumes in that first phases until you get your organic matter built, because you got to put an N in there to make more organic matter. That's why that requirement is in there. And then in 11 years to 20 years, C accumulation increases. Available water in the soil increases. End mineralization is greater than immobilization, so now we get some credit on the nitrogen. Increased carbon cation exchange capacity. Increased nutrient cycling. That's 11 to 20 years is where you start to get into that. Our high school kids are going over there and gone. You know, I have a field that's been corn on corn longer than you've been alive. I like to do that to them. Right? It's been corn on corn since 1990. Like, longer than some other people in here have been alive too. So, after 20 years, continuous flow of N and carbon, high residue, high water availability, high nutrient cycle, high N and P availability. Now that's assuming you've done everything right up into that phase. This is a friend of mine from Argentina that created this, okay? Cesar Beloso, 2003. Important points, look at the whole system. You can buy nitrogen, it's hard to buy carbon, right? So if you need to put a little nitrogen on to make more carbon, more organic matter, you maybe need to do that, even though it is high price. Society and stewardship, again, this is 1999. IKEA announced it is phasing out the use of old growth wood, and it's going to do all this stuff, right? This is what I call greenwashing. We have a lot of that going on now. Oh, here at United Airlines, we're zero net carbon. So they're going to buy some of your carbon so they can keep burning diesel fuel in their airplanes, right? Eco-labeling, the popular eco-labeling, growing worldwide. Again, early 2000s. Society wants clean air, clean water, productive, healthy soil, wildlife habitat protection, safe, nutritious food, and cheap food. And I think we can do these things. But I think we got problems with the whole message getting muddled by terminology. Organic. Well, they're doing tillage, for God's sake. That's not sustainable. But nobody's willing to stand up and say, whoa, wait a minute. That's not healthy. It's not regenerative. It's not any of those things. And we want to be nice. You know, we're Midwestern. This photo was taken between Kabul and Kandahar in 2002. A friend of ours was over in Afghanistan doing missionary work. He came home and his brother happens to be a no-tiller. And they thought maybe that would work in Afghanistan. So they managed to get a drill over there. And he's drilling, but what's the problem? There isn't any organic matter, right? They take all the organic matter off the field and haul it into the building, and they burn it and feed it to their goats and whatever. It doesn't work unless you have the organic matter. It isn't the machine. It's the organic matter, and you can't take it off. And I don't know how you rebuild that. This photo was taken in 1987 in Morocco. And this is a fort at Boulouan that was built by the Moors or the Moroccans way long time ago. And it's a pretty intensive piece of architecture, you know, probably 1300s or whatever. And they have disappeared. Their ability to farm and and grow things had disappeared, and we were supposed to go over there and try to help them. And first day we were driving around, we kept seeing these things, which they were doing tillage. It's a little hard to see with the lights there, but as a camel hooked to a donkey. And I was trying to get a picture of this guy, because I was kind of climbing through this hedgerow doing this, and all of a sudden I heard this shoof, and I went, and there's the big guy there is standing there. He's the owner, and the other guy is the guy running the outfit. And what that means is, come and I'll show you. And I had an interpreter along that could speak Arabic, and we had this discussion, and I'm asking him, why the camel and donkey? And he said, well, camels are very strong but very hard to train. donkeys are easier to train. So when the camels are small, we hook them to donkeys. They learn to follow the donkeys around. And then the driver goes out and drives the donkey and the camel follows, right? So that's hopefully a little bit like it's going to be with Sam and I, right? I'm going to be giving the directions, and he's going to be doing the work, right? But what they were doing with tillage is not different. This is a guy that worked for me at Redfield, if that was the same thing. But what they were doing with tillage is no different than what we do with tractors. And this guy actually had 27 tractors, but it was cheaper to do it with labor. Okay? He said, I got tractors, but I only use tractors when time is of the essence just to do tillage. I just do it with this. The people there believe, the workers believe that if you put two animals of the same species together, they can converse and conspire against the driver. So they'll never drive a team that has two of the same species. So anyway, that's what it looks like there. But this is what the result is. And that's not dissimilar from the United States. I mean, we just drove to Louisville. We saw this all over down there. What the hell are we thinking? Okay? And they've done it longer period of time, so this is as good as their wheat crop can get, because they've taken all the organic matter and stuff out of there. Take the E out of T, take the T out of can't. You can't sell no-till to a farmer on environmental benefits alone. If you do, they will go broke, and the miner-type people will buy the land. Environmental benefits need to be sold to the consumer, and I still believe that. If you want to plow, get a real plow. There's actually, I was driving that actually. There's a picture of me driving that thing. One bottom was going about 3.5 foot deep. To turn over, bring up the calcium and the gypsum on land that had been watered with high sodium irrigation water. But we were better off just to put it in perennials and leave it. But anyway, that's a real thing. So this is my daughter who now goes to Harvard. So that's a long time ago, standing in a lentil field. And there's a drill that we got out of Argentina. That's probably the best drill ever, but it probably won't get built in a sunset. So, questions? Anybody want to throw rocks?
First question was, how does carbon affect the soil?
Did I cover that? Right? It makes it hold more water, makes it easier to deal with, gives you a place to put a microorganism in. I mean, it controls everything. If you take the organic matter out of the soil, all you have is dirt.
What type of soil organisms stabilize plant carbon in soil?
Well, some people would say, I'm not an expert, some people would say fungi. I think you need them all. And I think you know if they're there or not if you've got those apex type animals. The guys at the top, the night crawlers and the earthworms and some of the bigger things. I think prairie dog's probably a bit big.
How much carbon is needed to have good soil?
And that depends on where you're at. Again, in the tropics, they don't need a lot of carbon to make a good soil because all the biology is happening up above. And I think it depends a little bit. If you're on a slope, it's going to take a bit more to hold it, and that kind of thing. Usually your carbon is more in the bottom. But I don't think you can put a number on that. It depends.
Dwayne, Alex has got a question.
Yes.
Hey, Dwayne. On a field of alfalfa, what's the best way to transition out of that? Rotation, that's the way to do it.
Well, where you live, most years, I would tell you to probably take your first cut of alfalfa and kill the second. And you can actually, now it's legal, you can grow that second till it's about ready to harvest, and you spray it with Roundup, and 3 days later you can harvest it for hay. I think that's still labeled. That gives you time to recharge water until next spring when you plant a corn crop. Be the way I would do it. We did that once at Redfield, and it was 88. You ain't got about this tall. So the corn did. It didn't do too well. But that's one way to do it. And you could maybe also try to put a weed in there in the fall if you had a nice wet year, put a weed in there in the fall. But I'd harvest the first one, kill the second one.
Dwayne, continuing on that same question, if you were to take off the first crop of alfalfa, and when you started growth on the next cut, can you go in with earlier maturing corn and crimp off the alfalfa?
Probably not.
Okay.
I don't know. Not something I've done, Sam. You know, this crimping thing is really harder for us than it is other places of the world because we don't have the bigger growing season. Yeah, well, Indiana, yeah, they, you know, whatever. But, yeah, in Indiana you might be, I mean, here you just wouldn't have the moisture, Sam.
Is no-kill farming worth pursuing? Is it realistic? Is it out of reach for us, like you were just saying? What do you think?
No-till?
Kill, no kill, no side, no death.
Oh, organic no-till? I was supposed to today, after my first talk, give a talk to California on organic no-till, nutrient management and organic no-till, but they canceled it because of COVID. I think the question is, why do we want to do that? I mean, we don't use very much side. We haven't really used fungicides and insecticides. Maybe used 2 fungicides in the last 18 years and no insecticide. We occasionally use herbicides. But if I have to trade that for any kind of tillage or lack of residue, I don't think it's worth the trade-off. So, but I'm going to retire, so we don't know what this next bunch of guys are going to try to do. I know that there's this big demand for people wanting to try to do that. But you ask them, what's it, even, I have a graduate student that's going to take her orals here in next month. And we were driving down the road one day this summer, and she said, but wouldn't it be better if we could do no-till organic? And I said, so what makes that better? Because organic rules are based on tradition. You know, this is the way we always did it. They're based on tradition. They're not based on anything in science. They're based on tradition. I said, so what makes it better? You know, if you want to come from the approach that let's try to do no-till and then limit this type of insecticide or this type of herbicide or whatever, I'm fine with that. If we want to be more restrictive and say we've got to do this and this and this as far as scouting before we use one of those, I'm good with that. But to just say I'm going to adopt all these organic rules that are all based in tradition. They can use saltpeter for nitrogen fertilizer. You know what saltpeter is? Sodium nitrate. So they can put sodium nitrate on a piece of ground. Does that sound like a good idea? But that's legal because traditionally it's mined. It's not manufactured. You can't use urea, which chemically you can't tell the difference between urea in cattle urine and urea in fertilizer unless you have a mass spec. It's very difficult to tell the difference. You have to do some pretty intensive chemical analysis. So why can't you use urea? Well, because we didn't have urea in the past. See, so I don't buy into that. Let's try to accommodate that set of rules because I don't think they make any sense. But anybody can do what they want to.
So what influenced you to go into the field that you are in today, and what is the most interesting thing you have learned?
Well, that's for Chris Nichols, and her dad was a farmer. I know that influenced her a lot. For me, my dad was a farmer, and that influenced me a lot, and I was born at a time when you really couldn't, for a couple of reasons, you couldn't go into farming. One was economics and one was Vietnam. So I went into science and then got back into agriculture, which, you know, if you like science and you like agriculture, we really need you. And I have 3 daughters that are all engineers. I wish they were agronomists, but you can do engineering and be a girl now, so that's good. Have one right up here too.
Implementing livestock onto fields again, talking about insecticide like Poron for cattle. What's your take on that? Is it more detrimental to acres that haven't had insecticide? And then what do you feel is a replacement?
Well, Poron on cattle, there's various Porons. We do use a bit of that, but we do that in the wintertime when there isn't a lot of functioning animals around, or, you know, insects. So we do that in the wintertime. I think it could have a real effect on the dung beetles and stuff. I think there's data that show that. So we're trying to avoid that. I don't know how you totally get away from doing some of that. So we're trying to walk that line by where we have the cattle and we pour them, and, you know, that hangs around for a little while. But we use a much less residual type product in some of them.
So if I were to take my alfalfa off and then bring it out to go feed it and then bring the manure back, am I going to get the same outcome as if I were to leave some of it in?
Well, what we're doing is feeding it on the field.
Okay.
So this winter, the cows haven't gotten there yet, but when they get there, we'll use a bale processor and put it out in strings on the field where we harvest it from.
What if you were to feed it in the feedlot?
You lose all the nitrogen. You get the phosphorus back, but you lose most of the nitrogen.
Dwayne, my question is, I'm in Kingsbury County. I got some land, corn, soybean rotation, but we've worked with a dairy farmer, and in this property we've had a big draw going down through the middle with a lot of saline salt. We incorporated, well, he actually incorporated planting Italian ryegrass in there. So for 15 years you didn't have any soybean crop that grew in that draw. In 1 year of planting Italian ryegrass, he took 4 cuttings off. He reapplied dairy manure twice in season. The next year, so this last year we had soybeans planted into the Italian ryegrass stubble. It was even Steven right across that draw, 60 bushel an acre beans. I was absolutely amazed how we transformed that saline salt spots to ground that was raising a crop. But are we sort of going backwards by putting the Italian ryegrass on there, taking 4 cuttings off, but we are applying dairy manure back on?
Yeah, I think it makes some sense. Putting a perennial in there would do the same thing, and by taking it off. So where did that salt come from? And it's not salt, it's fertilizer, right? That's what we learned this morning. Those saline spots aren't salt, it's fertilizer in there. But what are you taking out of there with the forage?
Well, we're taking out some salts, we're taking out some...
You're taking the fertilizer out of there?
Yep.
Okay. Now, you're giving it to the dairy guy, and he's putting the manure back in the draw.
Yep.
Where should he put the manure?
On top of the hills.
There you go. Because you got an excess of fertilizer there.
Well, because we didn't raise anything for years and years and years.
Well, no, because it's coming down
okay.
It's coming down the hill, because you're not using the water efficiently on that side hill, because all you're doing is corn and soybean. What percentage of the sunlight are you harvesting?
Well, not a lot.
Not a lot,
Yeah.
right? And you don't have cover crops in there. So you got water moving through and getting to the impermeable layer, coming sideways into the draw, and then coming back up, and that's your fertilizer from up the hill. So you know, if he's gonna feed that, that's fine, take the manure up on top of your hills, if it's okay with him.
Okay, so if I plant a corn crop in my bean crop, sell it as silage, put cover crop back in where I took the corn crop off, am I going forward in my carbon nitrogen cycle? Am I going backwards, or?
Well, on the bottom of the draw, you probably need to do that. On the side hills and the top, you probably need to get his manure back there.
Well, it's just really been interesting using that crop to change the dynamic of that soil in those low areas,
Because he was taking it off.
yeah.
And that's why that swath grazing, I mean that bale grazing thing works. You do the same thing in the bottom with a bale and take the bale up on top and then graze it up on top of the hill. That's the sweet spot, because now you've got the poop and stuff up there and the pee. Your nitrogen doesn't move.
Are you familiar with biochar and
Yes.
that versus organic matter in the soil, and just what are your thoughts on that? And then the terra preta in South America.
Yeah, well, again, the thing I said earlier about a rainforest, all the activities up here, right? And what they did when they wanted to grow vegetables and stuff, they would cut down the rainforest and they would smolder it, not burn it, not the hot burn like the slash and burn, but they would smolder it real slowly to make the char, and then that's the area they'd have their gardens in. I don't think it's an answer for us. I mean, my bosses and whatever, for a while, because there was grant money there, they wanted to do everything with biochar. But, you know, think about it. That's not an efficient thing to do with biomass, other than they were trying to create a soil, you know, and how they learned that they had to do that, so they had a soil that really had this functioning thing where you didn't have the whole rainforest involved. It was pretty interesting, but you know, we thought of trying to feed biochar to our cows so they could spread it around for us, but we never went there.
I have a question regarding a comment from your presentation earlier this morning, where you said it was time that we quit using fossil fuels immediately. Yep. And then I see some of this today is promoting the continued use of fertilizers that are considered harmful. And I'm asking the question, why does that get a pass and fossil fuels
Because I can make nitrogen fertilizer out of electricity. The Norwegians and the Swedish are already doing that, and if I put up a large solar array, which we're doing, we can make nitrogen fertilizer out of our excess electricity.
But currently our electricity is produced primarily by fossil fuel.
Well, not mine. You know, I think we all should have solar panels on our sheds and whatever and make our own electricity. Right now, the electricity we buy from the REA comes from coal in North Dakota. And I think they don't want us to do that because they have bought that coal and they want to continue to sell that to us. But I think we have to get to the point where we just say, no, we aren't going to use electricity that's made with fossil fuels. I mean, if we start today, I mean, where are we going to make it by 20 years from now? Maybe, if we really hurry. But, you know, this is similar to a conversation we had 20, 25, 30 years ago, and I said, well, you guys got to quit doing tillage. Oh, we can't do that. Same thing. I put in the John Kennedy thing. We got to quit using fossil fuels. They're too harmful. You know? So, because all this sequestration thing they're talking about isn't going to get us there. Trust me. Because it's too... I didn't talk about this yet, did I? What happens to the organic matter you put in your, say, Indigo gives you money, put organic matter in your soil. And they're watching it for you, right? That's their job, is to watch it, and they sell it to General Mills or somebody. Now, if you listen to that thing out of Scotland a few weeks ago. Temperatures they're going to stay, we're going to try to keep temperatures from going up more than 1.5 degrees Celsius, which is about 3 or 4 Fahrenheit. What happens to the organic matter that you put in your soil? What happens to the organic matter or the carbon that's in the rainforest? What happens to the carbon that's in the ocean if temperatures go up just that little bit? It's going to gas off. And you're going to have, even if you did everything as good as you're doing it right now, you'll lose organic matter, even if you kept doing everything the same way you're doing it. My daughter, that I had a picture of, she's a teaching assistant she's doing her master's at Harvard, but she's a teaching assistant in a class. So when that happened, her boss, the professor she's working with, has a model, and they ran 1.5 degrees Celsius in the model, put out the results, and send them to the kids and say, what's happening here? Why is this happening? And it was showing that it's increased in CO2, even though they were going to do all these sequestering things they talked about at Glasgow. That was all built into the model, but they did all that stuff they said they were going to do, be net carbon and all this stuff, and then they raised the temperature 1.5 degrees. They're gassing off a whole bunch more carbon. And I think we just have to, it's a little like I said this morning, you go in and the doctor says you've got a clot in the artery of your heart. You don't have much of a choice. You could say, oh no, I'm just going to ignore that. Maybe it'll get better on its own. You got to fix it.
We've only got about 4 minutes, so a couple questions, but I'm going to make one comment and then Dwayne can beat me up. And I think this is the important of the soil armor, the residue, to help keep the temperature of the soil cooler in our area.
Yes.
So just a comment, and then Levi, you got a question?
Dwayne, there's a real issue in the United States with chronic disease, cancer rates, inflammatory diseases, infertility issues seem to have spiked in the last 20, 30 years. There's some science out there that suggests that possibly our agricultural system and specifically chemicals like glyphosate are contributing to that. What science are you aware of, and do you think that it's
well, I looked at a lot of
role?
the stuff on glyphosate and stuff, and that's Dr. Bush is pushing a lot of that. I'm not sure that stuff's as solid as some people would like to say it is, but I do think the neonicotinoids that everybody has on all their corn seeds, I think they're relatively harmful because they're so persistent. I don't know what that does to humans, but I think it does things to animals. I suspect, like baby pheasants need to eat bugs. And we've got this stuff out there that's really good at killing bugs, and I'm not sure it needs to be there all the time. And that's kind of one of the reasons we never wanted to use a lot of insecticides. I think some of the herbicides are okay if my alternative is tillage. It's always one of those questions of can you do it without. And I'd welcome stuff that we could do alternatively. I think we could, this is an old idea of mine, but you never see a kochia plant start to grow after the 21st of June. Once the day length thing flips over, it doesn't try to grow. And I think we could fool kochia into trying to grow in the fall if we went out there with some lights at the right time of night. Right? Because you can do that in the greenhouse, screw plants up in the greenhouse if you just flip the lights on at the wrong time. But nobody does research on that. I think some of the stuff with the little electric things makes some sense, that shock a weed. Some of this stuff they're doing with the sensors and the sprayer things come on, that weed thing that, we worked with that in 1990. And it's a little bit non-predictable, but, you know, a laser thing to knock it out, I think would be fine, but if we're gonna put tillage back in there, we go backwards. Mother Nature really doesn't like that disturbance above. But we don't have that much. With our good rotations, we have, and lack of disturbance is one of the biggest things. We just don't have that much weed problem. And I think people who come and visit us are always just kind of amazed that there's not weeds other places, everywhere. And, you know, not say we don't have them once in a while, but not very often.
Levi's got our last question. We just got a couple minutes, you guys.
What does that drill from Argentina have that makes it better than the drills available to us?
It has a walking beam depth control. And Cindy was going to show my 1987 drill that had a walking beam on it before I saw the one from Argentina. By walking beam, it follows contours like this. It got 2 points of depth control, so you're doing this thing. And then the opener itself is an offset double disc with 2 different size discs. So one's running behind the other one, and the angular momentum is different, so it'll never hairpin. It's absolutely phenomenal. And he designed it to plant rice on terraces in the interior areas. They have hills like this that they put these terraces around that they flood to grow rice. And if he didn't have that drill, they have to go down there and then turn around and come back, and then they kept tipping over when they were trying to turn around on those terraces with drills. And this way you can just go right down the hill like this, and it'll just go over the terraces. And we've got all these damn terraces that people have to farm going around, and we could farm them going up and down if we no-tilled, right? Which would be nice.
You guys that hold your questions, remember them, because we're going to have Dwayne be able to maybe answer a few in a little while. But thanks a lot, Dwayne. Really appreciate it.
No, I'm done. I'm done.